Hello viewers, welcome once again to another video lesson. In today's class, we'll be discussing about one of the major and most commonly used branch of mathematics that we come across in our day-to-day life, that is known as statistics. So basically, the word statistics has its origin from a Latin word, status, or the Italian word statista, or the German word statistic, which means the political state. And further, it can be defined as it is the collection of data and its representation and interpretation. So, statistics has been widely used in the progress of a country in economics, politics, scientific relations, and various related areas. So, it has been contributed widely by the mathematicians such as Gauss, Pearson, and finally put to modern form by Fisher. So these are the different ways in which we can represent our collected data. For example, a bar graph to represent the rainfall in various months of a year. Then similarly, histograms are there. Then we are having frequency polygons for voting age of population. So various thousands of examples are there in which we can represent our collected data, okay, in terms of bar graphs, frequency polygons, and histograms that we'll discuss later. So basically, the topics that we have to learn in this chapter is all about collection of data, that how we can represent the data, and interpretation of data. Then different types of graphical representations are bar graph, histograms, and frequency polygons. And we have to also learn about the measures of central tendency, which are mean, median, and mode. So in today's lesson, we'll just continue with the very basic concepts of importance of collection of data and how we can represent raw data into a tabular form that we'll discuss basically. So let's continue with the concepts related to the collection and representation of data. So hopefully at the end of this lesson, you will be able to understand these following concepts. The first one is appreciate the importance of the collection of data, then distinguish between primary and secondary data. Then we'll be able to understand what is the frequency of a data and arrange given data in ungrouped and grouped frequency distribution tables. Okay. So, for example, these are the newspaper headlines of any given day. For example, Delhi records the hottest day of the year, then biggest fall in the Sensex in 5 years, then any data about the any sports person, then population data of any country, India's population to overtake China by 2030. So these are the few newspaper headlines over there. So you must have seen these headlines in the newspapers in our day-to-day life. So have you ever wondered that how these headlines are possible to get, because several persons and several organizations are basically dedicated to gather all these amount of data to give some statement. For example, temperature of different cities on some particular days, then rise and fall of Sensex, and scores of different batsmen in different matches, or the population of any country. So a systematic date record of facts or different values of a quantity is called as data. Okay, a systematic record of facts or different values of a quantity is called as data. And we'll see a few examples over here. So such records and data is collected over a period of years and months. So data is collected with some specific tabular representations, and the analysis of data can give us many different kinds of information. For example, uh, data collected regarding the population survey of a state. Uh, so we can see over here that different states are mentioned as well as with their populations. So the survey keeps on going for years and months to collect all this amount of raw data over here, the number of males and number of females and male and female ratio. So data is not just about population, as well as something lot of data can be collected, okay, now from the raw sources. uh, so for example, through opinion polls, election results, then satellite images, and much more. So various ways are there in which we can collect the raw data. Even the report card that you are getting after the on the result day, That's also the collection of data that shows your performance on the previous examinations. So basically, what we can see over from this is that the collection of data not only helps us to keep a track of current happenings and trends, but also helps us predict what might happen in the future, right? So this is the importance of the data collection and raw data collection from various sources with different methods. So now let's discuss about the difference between the primary data. So basically, the data collected by a researcher with a specific purpose in mind is called as primary data. Okay, and there are various ways through which we can collect the primary data. For example, questionnaires, then interviews, then we are having observations, opinion polls, case studies, okay, portfolios, etc. But it's really tough to collect the data personally, and that's why it is called as primary data collection, and it takes time also. So for example, you can give a numerous examples about primary data collections. For example, number of students in different sections of a particular class, or we can say number of computer systems in our computer lab. Then we can say about the telephone bills of our house for the last 2 months. So this data is particularly collected by a person himself by various measures. Then we can move to the secondary data. So secondary data is nothing but the data gathered from a source where it already exists. Okay, it's called as secondary data. For example, number of students appeared in an examination obtained from newspapers, right? Similarly, number of female teachers or male teachers in all their schools in a state or country obtained from the educational department. So such type of data is already gathered from a source, and you are gathering the data from a pre-stored source. Okay, so where it already exists, a website, it can be a website, it can be an organization which is collecting all that raw data and then providing and then forwarding it further wherever it is required. So such type of data collection is called as secondary data, which is already being stored previously, right? So students, next step is to how we can define the range of a given data. For example, on your screens, you can see the age of, or we can say some data is given, the age of different family members of a family. So the difference between the highest and the lowest values in the given data is called as the range of a given data. So here the range of the given data, as you can observe, it will be the difference between the highest value, okay, which is available, for example 95 and minus the 4. Okay, so for example in 10 innings the runs scored by a batsman are as follows over here. So highest run that he scored is about 95, and the minimum runs that he scored is 4. So the range of this data, this collected data in the given number of innings of that particular sports person, is the range of this given amount of data is that will be a highest value minus lowest value, that will be 95 minus 4. So the range of this given data will be 91. So in this way we can just calculate the range of any given data, right? So let's understand this concept with one more example. For example, this is the data provided of any batsman in which number of innings in which he scored these particular runs. Okay, for example, in first inning he scored 0, and in second inning also he scored 0. Then third inning, then up to 15 innings are given the runs scored by him. So in this way, we are representing the data in particular innings. Okay, in each inning, what runs he is scoring. So there is an much convenient and much easier way to represent this amount of data. So if we can write the same data in this form of table, this tabular form, so in which you can see that what we are doing, he scored 0 5 times 5 times. Okay, so total number of innings are 15. So he scored 2 runs and in 2 innings, and he scored 9 runs in 1 innings. So total number of innings were 15, and we are representing the data in such a way such that we are combining his scores. Okay, that in how many innings he is scoring given particular runs. So if some value is repeating, that we can write it all together. That's why it is called as frequency. So what is frequency? For example, in this case, the number of innings in which is scoring the same amount of runs. For example, in one inning he scored 20 runs, so frequency in that case will be, for 20 runs will be 1. Okay, similarly, in two innings, if he scored 49 runs, so the frequency of scoring 49 runs will be 2 only. Okay, so in this way we can make the table, and that's why it is called as frequency distribution table, right? Similarly, the frequency of scores, that is scoring in various innings, that can be represented like this. And this table was created to represent his scores in the last 15 innings. So a table that shows the frequency of different values in given data is called as a frequency distribution table, right? And the frequency distribution table that shows the frequency of each individual value in the given data is called an underground ungrouped frequency distribution table. Okay, so frequency distribution table, we are having two different types. We'll see that what are the two types. For example, uh, consider if this batsman scored, these are the scores in the last, let's say, last 15 innings. So frequency distribution table, if you are trying to show this data, it will be a very long table. Okay, so we have to make grouped frequency distribution table in which we can represent the data in a much easier and much convenient way. For example, you can see that the same amount of data, total number of innings were 45. So if you are representing the data inning wise, it will take a lot of time, as well as it's time consuming, and it will be hectic also. So if we can represent the same data in such a way in which we can represent the data in such a type of grouped frequency distribution table, that's why it is called as grouped frequency distribution table. Why? Because you can see that we are giving a range over here. For example, the range of the score is 0 to 9. So in how many innings he scored 0 to 9 runs? So that is number of innings as 12. So we can just count that particular scores which is coming in this range, then we can write it across to that, okay, in the given table. So each group has a fixed number of values. So a table that shows the frequency of groups of values in the given data is called a grouped frequency distribution table. So that was the basic difference between an ungrouped frequency distribution table and a grouped frequency distribution table. Okay. So in the last 45 innings, we can represent the data very easily in such a way. Okay. So the score that he got in the last 45 innings, we can represent like that. So this is called as grouped frequency distribution table. So in the first group, you can see 0 to 9, 10 to 19, 20 to 29, and fourth one, 30 to 39. So we used to group the values in the given data to make different classes, or we can say different class intervals. So these groups are called as classes or class intervals. So all the classes in the table have a class size of 10. Okay, that should be constant, and the number of values each class contains is called as the class size or the class width. So here the class size is 9 minus 0, that is nothing but 9 only. 0 to 9, if you're counting from 0 to 9, then the class size is 10. Okay, so all these class intervals are having the same class size of 10. Okay, and the lower value in a class is called as the lower class limit, and the higher value in a class is called as the higher class limit. For example, in the first class size 0 to 9, we are having the lower class limit as 0 and the higher class limit is 9, and the class size is of 10. Okay, 9 minus 0, similarly 19 minus 10, like that. Okay, so here you can observe easily that what are the lower class limits and what are the higher class limits. So 0 is the lower class limit and 9 is the upper class limit, or for the class interval 0 to 9. So next we are about to discuss the tally marks. So tally marks are also used to represent frequencies of different values in a frequency distribution table. So let's see how we can write the frequencies in terms of tally marks. For example, the scores are 0 to 9. In this range, for the score 0 to 9, number of innings, that is the frequency. So in 12 innings, the batsman scored 0 to 9 runs. Similarly, for the last class size, we can see for 40 to 49, That which means that in how many innings he scored 40 to 49 runs. So that is number of innings are 10. Okay, so this frequency we can also represent like tally marks. For example, in the first case, if you have to write 12, so let's see how we can write 12 in terms of tally marks. So first of all, we have to write four vertical lines. Then we have to the crosses with one slash line, one oblique line, which means that it is five. So then next you have to write five. So four vertical lines, then one oblique line to cut it out. So five plus five, then two, which means that that is so for let's see how we are writing five over here. Four vertical lines and one oblique line to make it five. Then five plus five, 10. Then 10 plus two, for two we have to write two vertical lines. So in this way we can write 12. Okay. Similarly, for 9, let's see how we are writing. Four vertical lines, then one slash, which means that it is 5 plus 4 vertical lines again. So in this way, we can represent the tally marks for the given frequencies. So let's take one more example. For example, in a given examination, the marks obtained by various students, okay, total number of students in the class are 59. So the marks obtained by the students in the given range, that is given as 41 to 45. So that is the first class interval, and the class size is 5, okay. And number of students who scored the marks in this given range, that is given over here. And for example, if one student got 85.5 marks, so if you can observe in this table, there is no class size for that mark 85.5, because in the last fourth class size, if you can observe over here, that we are getting 81 to 85. Okay, so if someone is scoring from 81 to 85, then we can put that student in this table over here as the frequency. But if someone is scoring in between 85 to 86, then where we have to place that student. Okay, so for that we have to change this class intervals, and there is a particular method that how we are changing that. For example, if some students are scoring the marks between the range 41 to 45, then we can easily put that student in this first row. But if someone is scoring 45.5 or 45.7, that is in between the range of 45 to 46, but no specific class interval is there for that particular mark. So in that case, we have to change this table, okay? And let's see how it is done. So to change the class interval of a frequency distribution table, the first step is to consider any two successive classes in the frequency distribution table. So let us consider the class 81 to 85 and 86 to 90. Okay, the second step is to find the difference between the upper class limit of the previous class and the lower class limit of the succeeding class. Okay, so the previous class, so here we can see that in classes 81 to 85 and 86 to 90, the upper class limit of previous class, that is 81 to 85, is 85, and the lower class limit of the succeeding class is 86. Okay, so difference will be 86 minus 85, that will be 1. Then you have to do the half of the difference, that is 1 by 2. So that will be 0.5. So this you can find by taking any two successive class intervals. Okay, we have taken these two. You can take any other two. In all the cases, you will get the same result. And the difference that you will get is 0.5. Third step is to rewrite all the classes by subtracting the result of step number 2 from the lower class limit and adding to the upper class limit of each class in the table. So see how the table changes, what we are doing. The difference that we got by subtracting them, that was 1, and we divided that by 2, so we got 0.5. So whatever the result you are getting from there, that result you have to add that result you have to add in the upper class limit, and you have to subtract the same result from each and every lower class limit. So from here we are getting 65.5 to 70.5. Okay, so like this the table changes. The previously the table was like this. Okay, the first class size were 41 to 45, but after this result, we got the table changed like this. We are writing from 65.5 onwards. So you have to subtract this, okay, 0.5 value from all the lower class limits and adding in all the upper class limits. So in this case, you can see that now a number of students frequency, we can easily put that student also who got 85.5 marks. So the step number 3 that we did over here, for example, the class differences from 81 to 86 becomes, in the lower class limit, we are subtracting 0.5. So it becomes uh, 80.5, and upper class limit we have to add in that, so it becomes 85.5. So in this way the table changes, right? And now next we have the fourth step. Yeah, so 85.5 appears now in the two classes. So now where does this student's marks will be fitted, who is getting 85.5? So in such cases, what to do? So by convention, we include the new value in the class interval where it forms the lower class limit. Thus 85.5 is included in the class 85.5 to 90.5 and not in the class 80.5 to 85.5. Similarly, so for example, after changing the table, you can see that some values are coming two times. So you can see that the lower limit of this class is same as the upper limit of the other class. So if some student is scoring 70.5 marks, then we'll not include him in this class interval, but we will include him in this class interval that is having its lower limit as 70.5. And similarly, if some student is scoring 70.4, then we can easily include that particular student in the very first class interval. And if some student is scoring 70.6, then we can easily include that particular student in the second class interval. But for those exact cases, for example, if someone is scoring 80.5, so for 80.5 we cannot include that particular student in third class. Instead we'll include him in the fourth one. Okay, so for example, in our case, the marks score was 85.5. That's why we included that particular student in 85.5 to 90.5 range. So in this way, we are changing the class intervals for some such several cases that we'll discuss while doing the questions also from our textbook. So that was all about the frequency distribution tables. We studied about the primary data and secondary data, then how we can represent the data in two types of frequency distribution tables. The first one was ungrouped frequency distribution table, and second one much convenient, that was all about the grouped frequency distribution tables. So we'll discuss these concepts in our upcoming sessions where we'll be doing some more questions based on these concepts. So by that time you have to just go through with this video lesson and understand the basics of statistics, and we'll discuss with more interesting concepts in our upcoming sessions. That's all from my side in this session. Let's continue with more interesting problems in our upcoming sessions. Assalamu alaikum to all of you.